Welcome to the Robotics Through Science Fiction podcast. I'm Robin Murphy, and in this episode, I'll talk about Rendezvous with Rama, an old and goldie by Arthur C. Clarke, and it's a great example of the Gibsonian ecological approach to perception and ultimately cognitive science. Rendezvous with Rama is Clarke's other book about a robot spaceship. It was written in 1973, but it lives in that long shadow of the 1968-2001 A Space Odyssey, which was written by Clarke to explain Kubrick's movie, which was in turn based on a 1948 Clarke short story. Many sci-fi aficionados may not be aware of the book, even though it won both the Hugo and Nebula award. In this case, Rama is an alien spaceship, not a human-built one. But like 2001, the book offers a highly plausible examination of a way to reliably control a generation ship for millennia, though in a very different manner than how are Ilse and Longshot. The backstory is that an asteroid or comet is detected moving toward the sun, possibly on a long elliptical orbit, possibly to collide with the Earth. It's named Rama because all the names from the Greek and Roman pantheon have been taken. And then someone notices that it's a perfect cylinder. Alrighty then, it's a first contact scenario. Game on. But the cylinder doesn't respond to any type of signals. Are the aliens so different that we can't make first contact, or are they just out to take us over? A space transport crew is retasked to intercept and make first contact directly. Still no response. The crew is able to get on board and ride with the spaceship for a few days as it continues its approach to the sun. And inside, the humans witness a transformation as the ship is one big biosphere, a bit like Niven's ring world. The ecology transforms as the interior of the spaceship gets warmer nearer the sun and then starts triggering course corrections. There are no Ramans on board, but the ecology itself acts like a computer, making Rama a biologically controlled robot probe. Meanwhile, the humans are either ignored as they gingerly explore the interior, or they're treated as a biological infection. So much for first contact. Eventually, the humans have to leave, and Rama slingshots out of the solar system for the Magellan Clouds. If Rama was exploring for life, it wasn't looking for it in our solar system. And by the way, that wasn't a spoiler because there really isn't a plot with twist or character development to spoil. It is one of Sir Arthur's hardest hard science novels, where the science narrative trumps the minimal fictional narrative. The fun and the wonder of the book is imagining the world of the Ramans. Who cares about who is sleeping with whom and what the political plotting is going on? Clarke knew if we wanted that sort of thing, we'd be spending the summer rereading Shakespeare's plays. He knew what we really want is the look and feel of a new world and an alien way of thinking, and boy, Rendezvous with Rama provides that in full. And since Sir Arthur was the consummate scientist, he patented geosynchronous satellites after all, this new world is technically very accurate and offers insights into artificial intelligence for robotics. So, artificial intelligence used in most robots derives in some part from biological intelligence, particularly the concept of direct perception. And direct perception merits a bit of a roundabout explanation. A common assumption is that intelligent behavior is complex, that it requires a detailed representation of the situation or state of things, what we often call a world model, and that deliberative algorithms are constantly examining and reasoning over that world model to produce an optimal action. Well, that's certainly true for intelligent actions such as playing chess and solving mathematical puzzles, but other types of intelligence doesn't necessarily require world model or reasoning. Consider a cockroach. If you've ever encountered a cockroach and then tried to squash it, they exhibit a remarkable amount of intelligence. Most species flee when the lights are on. This is called a phototropic behavior, and it drives them away or repulses them from bright light. So they have this urge to go to where they perceive is the darkest place in their perceptual range. If the cockroach encounters an obstacle along the way, perhaps the surface of a chair leg, a wall, a person's shoe, they feel it on one side and just follow along that side while trying to get to the darkest spot. If they encounter a set of surfaces along the way that they can feel on both sides, like a crack, they try to go in and get completely surrounded. This is called an idiothetic behavior. Then they hide for a while with their internal timer clicking down. And if the lights are still on after the internal timer goes off, the whole process begins again. But since the lights are still on and the cockroach is already in a nice crack, nothing visibly happens except a twitch or two of the antenna. The cockroach did not have to reason about why the sudden change in light intensity occurred, the location of the chairs or walls or cracks. The concurrent urges from phototropism, from surface following, from ideatheticism were sufficient for action without having to understand or model what a chair is or a person's foot. Did the cockroach take the optimal path to the crack? No. Did it even know in any meaningful sense of the word that a crack existed or that it could squeeze behind that pile of books? No. Did it escape? Probably. Did it seem smarter than you? I'll let your significant other answer that. The point is that everything the cockroach needed to do the right thing to escape was there in the environment. It wasn't anything the cockroach had to model or learn or reason about. It was just like a light switch. If there's a sudden bright light intensity, flee. If there's a surface on your left, stay next to it and keep moving. If there's a surface on your left and right, crawl into it. In behavioral robotics, we say the cockroach is directly perceiving the world, that its behavior is an example of direct perception. The phenomenon of direct perception was first noticed and researched by psychologist J.J. Gibson during World War II. He led the team that discovered airplane pilots did better at landing planes if there were visible texture cues on the runway, those stripes, rather than just reading instruments. A pilot could quickly and reliably estimate the approach angle and speed if there were visible stripes in those lines of light, but they had much more trouble if they had to do a lot of math in their head to interpret instrument panel readings. Is 23 degrees too high or too low? Am I going too fast? So he called his work an ecological approach to psychology because he considered human cognition in terms of ecology, the human, the task they were trying to do, and what the environment afforded them in conducting that task, how they had co-evolved. This idea of the environment providing direct affordances rather than people sensing and then performing complex internal processes to recognize what was going on and determine what to do next was very controversial because psychologists were heavily invested in the idea of people being very deliberative and very complicated. Certainly people were above being influenced by their environment. That's what makes us special, right? But study after study bore Gibson out, and eventually one of the classic psychologists, Ulrich Neisser, essentially said, Gibson was right. There's definitely a part of the human brain that is reacting and exploiting direct perception without doing explicit reasoning. Not all of the brain, but some. And while the direct perception track of the brain is older and primitive and doesn't let us play chess or find our car like the new part, it's pretty useful. So we need to get over it and invite JJ to eat lunch at our table. Okay, let's all be clear that I'm paraphrasing here. Anyway, Neisser said something to that effect in his book, Cognitive Psychology, in 1967, which essentially created the field of cognitive psychology and is still a classic text. Meanwhile, at the same time, over in engineering, the first mobile robot, Shaky, was breaking new ground in artificial intelligence. It focused on reasoning, and after an initial set of breakthroughs in 1967, robotics went absolutely nowhere for over 20 years. The field got very good at planning optimal paths of a world model, but not at actually moving along that path or at building those world models. At the same time, Michael Arbib, a mechanical engineer who had attended the Dartmouth workshop that had created the field of artificial intelligence, he began to explore animal intelligence and brain science. And his rationale was, hey, look, wouldn't we be thrilled to create a robot as smart as a fish or a frog? The answer was pretty similar to what Gibson got, a resounding, no, we would not be thrilled, and leave us alone, you traitor to engineering, you've gone too biological. But fortunately, a new generation of grad students, in particular Rodney Brooks, Ron Arkin, and Dave Payton, read Gibson and Arbib and others and said, wow, this seems like it would work for some classes of robots, like a vacuum cleaner. Yes, the Roomba code was designed in the 1980s. It just took another 20 years for the mechanical components to get cheap enough to market it. Anyway, that began the breakthroughs that we saw in robotics in the late 1980s and early 1990s that got the field moving again. But even now, in 2018, most people, especially engineers, expect robots to need complex world models and algorithms that require high-performance computing and, well, just more work. There's an assumption by aerospace, mechanical, and electrical engineers trained in control theory that intelligence should be hard. And most of them are unaware of Gibson and Arbib. And if they are aware, tend to dismiss them, saying it never worked for anything besides the most trivial application. Enter Rendezvous with Rama. It illustrates how a generation ship, which seems pretty darn complicated and requires precise navigation, could be controlled with just direct perception. The ship gets near the sun, starts warming up the ship outside and in, ice in the biosphere melts into a sea, life forms start waking up or sprouting and giving off gases, and other life forms emerge from the sea and start patching up holes, and all this biomass causes the trajectory to be adjusted the way a sunflower tracks the sun. Saying direct perception won't work for robotics is like saying sunflowers cannot track the sun unless they have sextants. But to be fair to the hardcore physical engineers, there's one twist that Gibson didn't see coming. Since Rama is a generation ship, Clarke considered that Rama's biological entities would need to work over millennia. They needed to be resistant to genetic drift, and some entities were actually biots, part biological, part mechanical, hybrid biological robots. The biots got recycled, so they were part of the ecology, but they were partially mechanical, and that requires a lot of physical engineering. All right, my recommendation is read Rendezvous with Rama yourself and marvel over the enduring genius of Arthur C. Clarke. Then, if you're intrigued by the idea that the world is its own best representation, pick up a copy of Gibson's The Ecological Approach to Visual Perception. It's still a classic. Or find a copy of Rod Brooks' classic paper, Intelligence Without Representation, on the web.